Oh, you're supposed to record the start?
Yeah, because if you're absent, you want to hear the whole thing.
So that means they can hear me right now?
Kind of. More so me because I'm right here.
Whoa.
This is where you're going to turn your lab stuff in. This bottom one is just a blank thing, so a blank lab sheet. Okay, so that's on Friday. When the music starts, please get out your notes and flip over that chart. We're going to write on the other side, back by the water molecules. Ready, go. Okay, last week, because we did yesterday, we talked about how water molecules are like magnets. Take a look at that water molecule picture with your battle buddy. Discuss what a dipole is, what causes a dipole, and what makes it like a magnet. Dipoles, what causes it? Why is it a magnet? Ready, go. Water has a dipole because in a bond, electrons are being shared, but it's not like jelly beans. We're not sharing a thing. We're sharing energy. So the one that is more electronegative has a greater share, like a time share of the negative energy. So if Cole and I were sharing, I'm a lot bigger and stronger than he is. So I have more of a share of the electrons, which by comparison makes him positive. That positive and negative side creates a magnet. Those water molecules are very little, and they're actually, because they're so little and because how weak hydrogen is, it makes it a very strong magnet. So positives will attract to negatives. Draw a line, and let's talk about ions. New news. Arrows can go both ways. Reactions can go both ways. It's called an equilibrium arrow. One forward, one backward. Last time we learned that when we have the phase aqueous, that means it has been dissolved in water. Okay? So if we had some salts, table salt is sodium chloride, but any ionic compound is called salt. If we have some sodium chloride, it dissolves in water. What's going to happen is its ions are going to separate. An ion is something with a charge. An atom is not an ion. An atom does not have a charge. An ion does have a charge. It's a charge by gaining or losing electrons. So sodium has a +1 charge because it lost an electron. Chlorine has a -1 charge because it gained an electron. You have a periodic table of ions. If you don't know them, they also relate to the groups as well. Okay? So when I take some salt, I'm going to save that. Let's draw a beaker. Yeah, I do have sugar, so you're right. Draw a beaker. In my beaker, I have sodium ions. Ooh, I'm coloring. Come get colors if you want colors. And chloride ions.
It's a proven bag to help you retain knowledge better.
Is that actually proven?
Yep.
That's research based.
This really doesn't let us use color. She doesn't let you use color? Like she says, since it's not going to, you're not allowed to be that you should consider it. Makes sense. But
I don't know how it relates to English. I do a lot of research on learning. So, what I want you to do with your bad buddy is I want you to draw water molecules. So, figure out which side is attracted to what molecule, how come and why. Draw it in red, and then draw the dipole in green. That's what. If you're colorblind, I'm really sorry. These are both going to look great to you. Use your bad buddy to help you out. Okay? Draw your water molecules the right way. Positives and negatives. Ready, go. How? Those are different shades.
Those are the same color as the H.
oh, okay, yeah, that's
HOH is the same and the arrow is a different color.
What color is next to that purple up there?
Okay, we're not playing this game because we're learning. All right.
I think you should.
It's very interesting. Your negative side of the water molecule should be attracted to the positive ion. Opposites attract. Your positive side, which is the hydrogen side, which is the cold side, because he's weaker than me, is attracted to the, now it's to get his attention, attracted to the negative ion. This is called a particulate diagram, and it's big money on the AP exam. It's like 3 points for like 4 seconds of thinking. It's like the whole thing is not equally weighted, so take the easy points so you can get it. Yeah.
How would that actually react to just the soul?
Okay, so we're going to do that next. It's not a reaction.
They're not reacting, but like,
Does it matter what color like I put that stuff? Not really.
All right. This is a conductivity apparatus. When you connect the 2 probes, the light bulbs turn on. It's homemade. I don't know who made it, but it's like good to me. So obviously when I use metal to connect them, I complete the circuit and the light bulbs. All right. We are going to start with still water.
Did you accidentally electrocute?
I totally did, and it hurt.
what?
Did you actually?
Second hour.
Wait, how do you
I touched the 2 probe.
circuit?
I touched the 2 probes.
No, it like buzzed me really bad.
Do it. Oh, there's
Oh, let's do it. We all want to see you do it.
like how does
Oh yeah, I got a little bit.
wait, does that mean that he has like an option to do it or not?
Yeah.
No. Distilled water.
Please do it.
Distilled water is pure water. Tell your bad about it if you think it will conduct.
It's not gonna
Yes or
conduct.
no,
We did
right
this
inside
last
goal.
We did it last
It won't.
I think based on last week's cycle.
Okay. Okay, but now
Yeah,
I'm gonna take some salt. This is sodium chloride. I'm gonna pour it in here. Now this is what's happening.
I think that's not recording.
Yes, I am. I never stopped.
I thought it was right.
Whoever watches this is gonna be important. Okay.
Just switch.
I'm going to take some sodium chloride. I'm going to add it into the beaker. Now, what is happening is exactly what we've drawn. The water molecules, a bajillion of them, are very tiny, but they're also very strong magnets. And so these water molecules are getting in between the sodium chloride crystal and pulling it apart. Now, to our eyeballs, it looks like it disappears, and we call that dissolving. Yes, it is dissolving, but it also is another layer. It is dissociating. Okay. Dissociation is where we go from a molecules are made of atoms, to ions. Ions have charges. We look at this and it looks like it's disappearing, but what's really happening is the crystal is being broken up into its ions. Ions are too little for our eyeballs to see. These water molecules, negative to positive, positive to negative, are stronger of a force than this +1, -1. The attraction of the water molecules can overcome this attraction and it will separate it. Now I have in my beaker a bunch of water and ions. I have positives and negatives. Tell your bad, Lydia, the light bulb's going to turn on. Yes, no, right side, go.
Wow.
Anything that has a charge, anytime there are ions, it will conduct. It's called an electrolyte. Okay? But,
Electrolyte.
That's why they say
let's talk about sugar.
Wait, does Gatorade work? So if we were to put Gatorade in there.
Gatorade does work.
Gator-
Sometimes
Oh, wait, is that last
Gatorade
year?
is not good for you. A lot of body armor. That's like great. Gatorade has a lot of sugar.
it has so much sugar in it, which is why it tastes good, but
I prefer Badger Max.
Butter.
Badger Max.
I don't know. I've never heard that.
it's all some stuff.
Yeah.
Okay, it's sugar water with like a sprinkle of salt. Speaking of sugar water.
Actually, it's actually coconut water or vodka.
Oh, is it really?
It is.
Okay.
It's
Sugar. Sugar dissolves, right, to our eyeballs disappears, but that does not mean it's dissociating. Sugar is sucrose. Glucose is C6H12O6. Sucrose, I don't remember. I think it's C24H48O24. Either way, it's carbon, hydrogen, and oxygen. There is no metal. None of those have a positive charge. This is a molecular compound. That means that it dissolves, but it does not split up into its ions. There are no positive charges, there are no negative charges. All that happened was the sugar crystals just got smaller, so you can't see them. They still stay together. So knowing that it dissolves, but does not dissociate, tell your battle buddy the light bulb's going to go on. Ready, set, go.
Yes.
No.
Oh, that's important.
No ions, no light. Electrolytes have to have ions. These do not have ions. Nothing dissociated, just got too small for us to see. Vinegar. Yeah, there was kind of a lot of sugar. I was like talking about it. Vinegar. Vinegar is actually acetic acid. Acetic acid is a weak acid. Okay? I like
salt
it right
vinegar
now.
chips.
My kid loves salt and vinegar chips and makes me sad. It's too spicy.
Spicy.
Like the
I kind of
on your tongue, like it hurts.
Oh yeah.
I like spicy food, like I love spicy food, but vinegar. All right. People take shots of apple cider vinegar. It's good for your body.
I do that for fun.
Okay. Weak acids dissociate just a little bit. Some teensy amount of the hydrogens, H plus ions, will dissociate. They'll come off. Only some. Okay? So because we have some ions, not very many, not like NaCl, all of you, what do you think is going to happen to the lead?
Light up a little bit.
Just a smidgy bit. Weak acid. Yes, Paul.
So if you were to touch the prongs right now, would you get electrocuted?
Yes, we already talked about it. It hurts. Salt, all ions, lots and lots of ions.
Oh, that's why it's crazy.
Weak acid, just a teensy amount of little tiny H pluses. Okay? So now you have a chart. Can you flip your, oh boy, I forgot to copy the chart. Flip your sheet over. Let me grab the chart quick. So, a salt is a metal and a non-metal. The metals are to the left of the staircase. Most of the periodic table are metals. The non-metals are to the right of the staircase. So if I pick one of each, that's called a salt or an ionic compound. Those are strong electrolytes, and they dissociate into ions. Have charges, not molecules. If there is ions, then there is light, and they do conduct electricity. Molecular compounds are all nonmetals. Carbon, hydrogen, and oxygen, sugar, all nonmetals. They don't dissociate, they just dissolve. That means there is no ions. They just get smaller and smaller crystals, so you can't see them. They don't actually break into like carbon plus 4 or 5. They are called non-electrolytes, and they do not conduct electricity because there are no ions, even though they dissolve. What? Strong acids, there are 7 of them. You are going to have to memorize them, but not today, but later this week. They are also strong electrolytes. I didn't want to get out a strong acid because then I'd have to get goggles and all that stuff to show you, and it wastes it. They are strong electrolytes because they dissociate. That says dissociate into H plus ions. Lots and lots and lots and lots of H plus ions. There are ions, there is light, there is conductivity. Yeah.
So it's H plus and like something else as well?
Yes. Strong bases are in this black boot right here. These are the strong bases. You have to memorize them, not today, but later this week. Okay? It looks like a boot to me, so I I call it the hydroxide boot. It's like lithium hydroxide, sodium hydroxide, potassium hydroxide.
It looks like one of those old telephones.
Yeah, sure. They are strong because they don't dissociate into hydrogen, but they dissociate into hydroxide ions. If there is an ion, there's going to be light. Light conducts. Means it's a conductor. Oh, I know what you're talking about. Weak acids and weak bases are weak electrolytes. Because just a teensy amount of ions, teensy amount of ions.
We let her write that on our.
No, that goes under like boy name. Don't say it. Think of it don't.
Very small now.
Yes. So it conducts a little bit. The light bulb goes up a little bit. How you know if something is a weak acid or a weak base is that because it's not strong. You memorize the strong ones and all the other ones have to be weak. Strong, weak, non.
So what is non?
Non means it does not conduct electricity. The light bulb does not turn on. It's a molecular compound. There is no ions. Okay, when the music starts, summarize this whole table in 30 seconds or less to your partner, and then listen to their summary. So just because you wrote it doesn't mean you've learned it. Just because I said it for sure doesn't mean you learned it. So you need to say it, and you need to hear somebody say it. So take some time and take turns. Everybody summarizes it. Ready, go. What album?
It was.
Okay, draw a line. Flip it back over to the water page. Let's take some more notes, draw some more things. We know that if something is aqueous, that means it dissolves in water. And we now know that when something dissolves in water, if it is ionic, that it will dissociate into its ions. So when the music starts with your band, buddy, see if you can figure out what these two would split into, what the other side, and balance your equation. Don't forget to balance the equation. Ready? What are those ions? Set? Go. I'll put it back. They're equilibrium arrows. So arrow forward, arrow back.
Why are we writing this?
Oh my God, do you need like somebody to sit next to you? Okay, well then help him so he doesn't get frustrated.
I thought we were still writing on it.
You are?
We are still writing on it.
No, we're underneath that. It doesn't matter where you write it. Pull your head. You're better.
Dude, I do like gold hat.
And when you're done, get out your gold packet and help your battle buddy find the right page.
Who spreads that rumor?
Okay. Not all ionic substances will dissolve. Okay, it's called solubility. In honors chem, or if you did, if you did take base chem, we had like this big matrix thing, and that's how you learned whether something was soluble or insoluble. Now, Cole, you have these rules here on this top chart. So the first part of the top, or the top part of the first chart, is all the things that are soluble. So if something is soluble, that means that its phase is going to be aqueous. So just there we go. If it says it's soluble, that means its phase is going to be aqueous. It will dissolve and dissociate. If you find out that it's insoluble, that means that it will not dissolve, it will not dissociate, it is going to become a solid. And it's like they're not like hard and fast rules in real life, but we're going to follow them like they are hard and fast rules. Some things dissolve, but it takes a long time. Some of our stuff I have to put on a spinner and boil it for 24 hours to get it to dissolve. Some things like salt will basically just dissolve on their own. It just depends. Yeah. Okay, so the top part are all of the soluble things. So let me just explain the chart for a second, then I'm going to have you look at it. It says compounds containing NO3 minus. NO3 minus means nitrate. Feel free to use that post. I still use it. So like learn the names of your ions. Those are the most common ones. So all nitrates are soluble. It doesn't matter what it is. It could be iron nitrate. It could be calcium nitrate. There are no exceptions. Every single time it's going to be soluble. Acetate, CH3CO minus is acetate. All acetates, doesn't matter what it is automatically going to be AQ. There are no acetates that are solid. Okay? If it's dissolved. If you look on the bottom part, those are the insoluble. So most of the time, any sulfide is going to automatically be insoluble. The exceptions are going to be ammoniums and alkali metals. Alkali is this first column. So sodium sulfide is aqueous because it's an exception. Okay? Take a second, look through this chart with your battle buddy, just like talk about it. Make sure you understand how to read it before we move on. Ready? Go.
Hey, that's just wrong.
Okay, draw a beaker. Back on wherever you were doing this on your color sheet. In your beaker, we are going to draw just the ions, not water molecules, just because it'll just get kind of crowded. I'm going to use red for positive, green, for negative. So my red ions, I'm just going to do in red to kind of make a point. I'm also drawing them proportional, so that means I'm going to end up with 2 nitrates, because when I balance my equation, I would 2 moles. Do you know, well, there's only 4 girls in here, but the old Girl Scouts on Navy Boys. Make new friends. Make new friends, but keep the old. One is silver and the other is gold. Okay, so kind of like that. When they get in the beaker and the water dissolves them, how do I know the water is going to dissociate them? Because they're aqueous, they're soluble. So what's actually happening in that beaker is it's not a crystal, it's potassium ions, iodine, lead ions, and nitrate ions. There would be nothing that would stop this positive from being attracted to that negative. There's a gajillion of them in there, and they're all moving around. There is nothing that would stop this positive from being attracted to that negative. There's a gajillion of them in there, and they're just all like little magnets. Okay? So, let me show you.
I didn't use the colors, but nitrate, like
That's by the aerosol.
that's unfortunate.
So you can go any company. There's something called equilibrium constant that shows which way more likely.
What is
Alright.
that thing with the red?
This is, I'll show you. This is potassium iodide. It's AQ, meaning it's dissolved in water. It used to be a powder. We added water to it. It's going to be a colorless solution. This is lead nitrate, lead 2 nitrate, same thing. This is called a pipette. Instead of using a graduated cylinder, so like when the mouth of the bottle is like wide and be like awkward, I have to get a formula or something. We just use these. These are super neat. So it measures volume just like a graduated cylinder does, but all you have to do is you stick it in there and you crank this and you can like decide how much you want. And these go up to like 25 mils, so they're super convenient. I'm just gonna grab a couple. Yeah, it's like a turkey baster. And then when I want to, I'm just gonna plunge this into here. But first let's talk what's going on. So in this test tube, I have potassium ions and iodine ions, right? Dissociated. It's ionic, water's in there, they got up all in there like little magnets, separated out. In this pipette, I have lead ions and nitrate ions, all separated ionic. And I'm going to mix them together.
Whoa.
Okay.
It's yellow.
It looks like, to your eyeballs, it looks like I made a yellow liquid, but I didn't. What I did was I made a yellow powder. It's just a really fine powder, so it's floating around in the liquid. If you look, no, it's lead. It's actually if you look at the ones from earlier today, you can see how the powder settles down into the bottom eventually. It looks like a yellow, but it's not. It's just a really, really fine yellow powder. If I let it sit, the yellow powder is going to sink to the bottom, and just the colorless stuff will be on top. What does this mean, though? This means that one of these combinations is insoluble. One of these combinations became a solid. So with your battle buddy, we're going to write a whole reaction here. So what did I do?
I figured it out.
Yeah, it's not that hard. I took potassium iodide, AQ, and then I poured in some PbNO3, lead to nitrate, AQ. They were both dissolved in water, so all these ions went in there. Go ahead with your battle buddy and write your two products and figure out phases. Which one was insoluble? Which one is the yellow powder? Don't forget to redo your ratios. There's got to be a ratio of 2 nitrates to 1 lead, but the ratio from potassium to nitrate, K to NO3 is just 1 to 1. They're both +1 -1. So make sure you have a +2 -1 that you bring down that 2. So that yellow powder is lead iodide precipitate. We call it a precipitate when we make a solid. Okay? So now let's draw that in a particulate. This is the last particulate diagram. When we make a precipitate, we draw a mound on the bottom to show our reader that we understand that it would settle out to the bottom. We label it as a solid. So they know that we know that it's insoluble. Our KNO3 is aqueous. Aqueous really means that it is dissociated into its ions. When things are aqueous, they also have water molecules in the correct orientation, positives to negatives. Anytime we draw a water molecule, we must also draw a dipole to show the positive side and the negative side. These are big money on the exam, 3 points. Sometimes it's 5 minutes of math to get 1 point. This is like 2 minutes of drawing to get 3 points. It's so inequitable. This is the move. Yes.
Would that light up the light bulb?
Yeah, it would because there's ions. Right? Anytime you have ions, you're going to have light. Okay, when the music starts, talk about this particulate diagram, all the parts to it. Make sure you understand what these arrows and pluses mean, and then turn your PowerPoint notes to the sample problems. We're going to do a sample problem. Ready, go. Okay, number 1. The accompanying diagram represents an aqueous solution. It's either going to be magnesium chloride, potassium chloride, or potassium sulfate. With your battle buddy, do sample problem 1 and write the equation. Figure it out and write the equation. Ready, go. Record. It has to be potassium sulfate because there's twice as many potassiums as there are sulfates. Let me talk to you about homework. So in Schoology, in your chapter 4 folder, there's a folder called homework and then a folder called answers. I guarantee you things are going to be in the wrong space. Somebody just has to tell me. Like, I'm not that good at detailed stuff, so there's a chance there's like 100% chance at one point it's going to be
They're
wrong.
alive. No, it's not. So,
I don't have attention to detail. I'm a big picture person, so things get shoved in folders. Like I just started like naming these things that made sense instead of like blue worksheet 17. So anyways, this worksheet packet, I'm not kidding. This worksheet packet is multiple pages. It's about 20 pages long. We do not do all the problems. This is a shared document with AP chemistry teachers all over the world. The answers are very easy to find if you want them. I will always post my work and my answers. I used to print them off, but at the end of the year, it's like people were throwing away blank packets. If you're not a homework doer, then it's such a waste of paper. Right. So I would suggest to you downloading this so you can have multiple windows open, so you can have the answers open as well. What I'm asking you to do is 1 through 7 on reactions and aqueous solutions 1. It's just practicing writing these formulas and with these particulate diagrams, okay? If you are for sure going to be a homework doer, then print the packet, and then you can just have paper copy of it, and you can like take it to wherever you want to do. If you're like, sometimes I'm going to do it if I need to, then I wouldn't bother printing it if I were you. Okay?
Like 20 pages, like the whole